Welcome to Citrix Converge and welcome to my session, which is using SD-WAN to seamlessly link multi-cloud. This is something I'm quite passionate about, purely from a technical standpoint. So I'm Lee Jeffries. I'm an independent IT consultant in the UK. I maintain my own blog and I'm active on social media. So please give me a follow and check my blog. I'm a current Citrix technology professional and a login BSI technology advocate. I love working in the EUC space. It's always evolving and changing, which keeps it fresh and interesting. I work on a range of different products, from virtualization, from the hypervisor stack, right up to virtual apps and desktops, different methods of app delivery, and through to networking products, so ADCs and SD-WAN. So a pretty broad product stack there with a range of experience. So what do I want to talk to you about today? I want to cover SD-WAN, and I know this conference is supposed to be developer orientated. There is an API for the SD-WAN devices, and it's progressing in the direction with products like SD-WAN Orchestrator, which is a cloud run product. There is an on-prem version, and that really is designed to replace some of the methods that I'm showing you today. But at the moment, it coexists. The methods that I'm going to run through today will coexist with SD-WAN Orchestrator. But the idea of SD-WAN Orchestrator is that it manages your SD-WAN appliances for you. So we're essentially going a bit old school in this particular overview and setup. But what I want to highlight is really the feature set of SD-WAN and how that's a benefit to people. So we're going to cover what SD-WAN is and what it does. Also, the multi-cloud part. So I wrote a blog post on multi-cloud and we'll cover some of the sort of outputs of that. How to set it up. I'm going to try and bullet point this because it's not the main focus of this session, and how to set it up. Yes, I've done some video walkthroughs and I've presented this previously and how to set up the whole stack. My blog post is going to cover that. So I'll be covering the bullet points and explaining some of those, running through those, but not actually showing you how to set it up live on screen. We'll go through costs and how I manage that, and using Streamdeck in a lab environment. So I use SD-WAN in my labs, and I've got a Streamdeck, and I assign some nice automation. I'm going to share those scripts with you at the end. So the idea is, if you follow my blog post, you'll be able to set up SD-WAN, create a multi-cloud mesh, and then you'll be able to assign some nice automation to the Streamdeck, or just run the scripts manually, and that will power on, power off the devices for you and give you some nice little notifications whilst it's doing it. So what's SD-WAN? So SD-WAN allows us to use multiple internet connections, or multiple connection types, I should say, for different things. So if you imagine we want to send all our internal traffic across our MPLS, and we want to have our internet breakout going externally, which is sort of a traditional model. What happens if our MPLS breaks? We have a problem because all of our internal traffic ceases to flow. So what SD-WAN does is it will mesh all of those connections together and create a logical link that runs over the top of that physical networking layer. And then all of that traffic that flows over that overlay network is what it's called. You can look at and you can prioritize and categorize. Okay, so you can see here in this example, I've got MPLS, internet, and LTE satellite. And this is a stock diagram. I've not done anything special here, but I'm explaining here how you can mesh these different types of networks. So the logical link created between the sites, that's the red and the green. Okay, that allows us to look at the traffic that's going over the link, to understand which applications via the packets that are going across, and what we can do with those. So we can actually have, for example, Office 365 could break out to the internet. So rather than that flowing over our MPLS, going to our main internet breakout for a business, we could actually break that out locally at our branch site if it has an internet connection, which it would, right? Because you wouldn't just have one link if you were using SD-WAN. You'd always have two because you want that resilience now. And we can also look at the packet loss and latency of a connection, which is advantageous, right? So if we've got multiple service providers, SD-WAN will prioritize the traffic over the best link you have, And it will also tell you, it'll give you the stats to go back to your providers and actually tell them you have a bit of a problem here. So SD-WAN gives us a network overlay that sits over your current physical network and gives you full visibility of all the traffic and the ability to be able to prioritize it. So that sounds pretty good, right? And my quote, and what I always use and always tell clients, is that SD-WAN is what virtualization was. So it's basically hypervisors for networks. So you're virtualizing your network, which is pretty cool because it doesn't matter what type of link you have, whether it's a private MPLS or a public internet link. And you can just have as many of those as you like within reason on your device. And that allows you to create this really strong overlay network. So what about multi-cloud? I've talked about multi-cloud. Obviously, a lot of workloads for businesses are moving into cloud environments. And not all cloud environments cost the same. However, by tying yourself into a single provider, you sometimes have issues with downtime or service impacts. So you want to be in a position where you're actually able to offer multiple cloud providers. And this product allows you to do that. So we have the option of having resilient connections, multiple connections that are merged on the SD-WAN devices. By default, the intelligence across those lines gives us reliable connectivity, visibility of what's going over it. Then we can add application-aware routing, quality of service, and dynamic routing is supported. So if we add a network at a branch level, the SD-WAN devices can just be told about that or integrate with any dynamic routing protocols you have, so OSPF or BGP. So we have our ability, by deploying these devices across multiple cloud providers, to actually deploy whatever we want, wherever we want, with pretty low latency links. So Citrix SD-WAN is currently supported in AWS, Azure, and Google Cloud. I think there's actually a couple more now of the smaller providers, but they're the three big main ones, and they're all supported. There are also physical appliances and virtual appliances for on-premises deployments. And I've put a quick screenshot here and just did a snapshot of a couple of models that are available and what they look like. Okay. So how do you get set up? Let's just talk about some of the terminology and then we'll look at some diagrams and I'll elaborate on those. So a few terms. We have our MCN, which is our master control node, and that is sort of your base. That's your first appliance you deploy. That controls your configuration and your change management. So it has your configuration editor actually on it, and this is the appliance that you would edit the configuration for all the other nodes. Okay, so it's a bit of a library of everything. So all the configuration happens on the MCM. The configuration packages, which are actually zip files with all of the config in there, they're created on the MCM. You download them and then you upload them to your nodes. There are certain terminology which could get a bit confusing, like your zero-touch deployments, and SD-WAN Orchestrator also does this job. So depending on how you deploy the products, as I said earlier, SD-WAN Orchestrator, I've not been able to get my hands on that yet to actually fit this into the process. But that's the way it's going to work. So what about multi-cloud? What does that look like? So this is in my blog post, and we've got cloud provider for Azure, Google Cloud, and Amazon. And what I've actually done is deployed an SD-WAN appliance across all of those. My MCN, that master control node, sits in my home lab, and that's where I do all of the configuration from. So I've just blanked out the public IPs because I've changed them since I published the blog post for obvious reasons. But that's sort of how it's all linked together. So an SD-WAN appliance has 3 network connections: management, WAN, and LAN at a minimum. And you can have multiple WAN connections. So I actually mesh this, and the routing between the cloud providers is direct. So in a traditional deployment or a network deployment, you tend to have an MPLS network between all your branches, which is a private network, and then you have your internet breakout at your main head office, or maybe at a couple of different sites. But you always have all of your traffic for internet basically backhauling to your main branch site. And this is an example of how that would work. Using SD-WAN, what I've done is I've simulated that process. So before meshing my network and allowing all my cloud providers to talk to each other, what I have here is I have my home lab as sort of the network bottleneck. So any traffic for internet breakout goes via my home lab. So between Azure and my home lab's pretty low, 27 milliseconds. Between Google Cloud and my home lab to the internet, what I've actually got is 68 milliseconds. Actually, this is from Azure to all of the other cloud providers. So going from Azure to my home lab is 27 milliseconds. Azure to Google Cloud is 68 milliseconds, and Azure to AWS is 58 milliseconds. Once I mesh these networks, however, this is what I see. So Azure to each cloud provider. So my home lab's pretty much the same, 25 milliseconds. Azure to Google Cloud, 25, and then Azure to AWS is 18 milliseconds. So by meshing these networks, you get very low latency links with visibility and the application aware routing that we talked about. So how do we get this set up? And like I said, these are bullet points. So I'm just going to elaborate on each of these. And then once I've done that, we'll get to the scripted part. I'll give you some links so that if you want to go and set this up and you want to work on this, you'll be able to use those. So how to get this set up? We import an appliance, or we power it up if it's a physical appliance. We assign a management IP for it, and that's our MCN node. We tell it it's the master control node, and we license it. Citrix gives you a license, as it does with most of the products they already has, like ADCs. You create an initial configuration for the MCN node. So the MCN has the configuration manager and the editor. However, you actually publish a configuration to the MCN to tell it which WAN connections it has, what the IP addresses are, which LAN connections it has, and what your subnets are locally. You then create that configuration and you publish it. Then you create a configuration for each remote site that you're going to have, and it's exactly the same stuff. You tell it what its WAN connection is and what its LAN connections are with the subnets, and that gets added to that whole library of everything else. Tells the MCN where these networks are and how to route to them, and you publish these packages through that change management process. Once the nodes are all connected, the change management process is automatic. It will automatically publish those packages, so you don't have to then worry about having to download zip files and manually upload them. Okay, but when you first configure your remote site, that first initial configuration is with a manually generated zip file. So that'll take you between 30 minutes to an hour, right? And I'll show you a few different blogs that I have on how to do this stuff. So there's a blog about multi-cloud meshing. That's a 6-part series. So that's quite a long one. That's going to take you more than 30 minutes to an hour because you'll be deploying an appliance on each cloud provider. However, you don't have to do them all. You could just do 1 or 2, doesn't matter. There's a blog about small lab setup, and that's running on Zen server, and we'll show you the basics of setting up SD-WAN and then how to just get 2 appliances talking to each other. Okay, so they're very step-by-step, loads of screenshots, loads of explanations. If you need any feedback on that, reach out. I'm active in the community. Okay, so what about managing costs and Streamdeck? I talked about costs, and I use these devices in my lab environments. So I have an appliance in each cloud provider, because if I want to use a cloud provider, I don't want to stand up a domain controller in that cloud provider. I want a link, but I don't want to pay for that link monthly every single time, right? And if I'm not using it, I'm just going to be paying money for no reason. So I don't want to do that. So what I do is I deploy these SD-WAN devices, I put them on slow storage, and when I'm not using them, I have them turned off. And what I have is Streamdeck on my desk, and I use that to power those devices on. So what I've done is I've generated a PowerShell script for each provider where I just put in the VM details, and I can push a button on my Streamdeck and it will power on that node for me. There's the link to the GitHub repo. And then this is a screenshot of the notification you will see. Okay, so let's have a look at these scripts and see if we can get them configured and working. Okay, there's a Streamdeck. There's the UI for it. Fantastic. There's the GitHub, and here are the blog series that I talked about earlier with the cloud mesh. So just go on my blog, put in SD-WAN, and you will pick up all of these as well if you don't remember the links. Cool. All right. So on GitHub, links in the presentation, just download the code to a zip file. Fabulous. And then we have it in the downloads. Right, cool. So we'll just put that in the folder, and then I will take that and pop it somewhere. So we'll pop it directly on my C drive. Excellent. And I will open up the Azure cloud as an example. All right. So read the comments at the front of the script, because that tells you how to set it all up, depending on each cloud provider and which one you're using. And here I'm using Azure RM, so I need that as a module, and I'm using Burnt Toast as a PowerShell module. That's the thing that's going to give me the little notification when I press the button. So I need to fill in some details for my Azure account. So I'm going to do that now. So my VM name is SD-WAN01. My resource group is RG_Citrix SD-WAN, all very original stuff. And then the service principal name that you set up, that's detailed here. So you want to do this from the Azure shell on the web interface in Azure RM. All right, and then I've actually got the details, and I'm copying and pasting them across because obviously I already have this stuff set up and running. And then you need your tenant ID. Okay, obviously I'll be changing this because I don't want people to be powering off and on my machines or accessing my subscription. So Azure Cloud, perfect. Right, excellent. So I know where that is. This is the folder. So in the GitHub repository, I give you the command that you need to use. So we just hop over to the Streamdeck. We want a system and open action. We drag and open. We will call this SD-WAN. We'll change the icon here. All right, so we will set this to our VM automation. We want the Azure icon, lovely. And then we take this and we just amend this path here. Okay. So our actual script is in a slightly different location from this. So we just pop that in there. Lovely. And that's us. We just run that from the Streamdeck now. So you see a quick PowerShell pop-up, and I've got focus. Here we go. All right. So you can see that I've run that. It's powered it on, and then it's powered it off. So we are good to go. So whilst I've turned the SD-WAN device on, we obviously need to make sure it's there and responding. So we'll send the old traditional networking troubleshooting ping. The LAN IP address for that SD-WAN appliance is 10.0.1.4. So we'll just send a ping there. Excellent. We can see that's now up and available, so I can access all my Azure compute and resources from my lab environment. Cool. So that's notified me now that my SD-WAN device is being powered on. Okay, so that covers an overview of the scripted process in order to be able to get SD-WAN up and running. And then that's the end of my session. So from this, hopefully you've got some steps to enable you to deploy SD-WAN if you want to. And then you've got some scripts to help you manage costs and let it be a little bit more ad hoc usage rather than leaving it running all the time. Thanks very much.